Today we will represent the numbers 87 and 35 in base 5. We are going to be using units, which are worth 1, longs, which are worth 5, and flats, which are worth 25. Now we are going to start with the number 87. How many flats can I use if each is 25 to get the biggest possible, to get closest to 87? We can use 1, that'll be 25, 2 to make 50, 3 to make 75. Now, we can use 1 long to make it 80, a second long to make it 85, and 2 units to make it 87. Now, for 35, let's remove these. We can use 1 flat, which will be 25, and we can use 1 long for 5, so that would be 30, and we can use a second long for 35. Now we're going to continue, and we're going to represent the number 341 in base 5 blocks. We are going to be using units, which are 1, longs, which are 5, flats, which are 25, and blocks, which are 125. To start off with, we're going to start with 2 blocks, each of 125, making 250. Now, we're going to add 1 flat to make 275, a second flat to make 300, and a third flat to make 325. Now, we're going to start adding longs. With 1, it's 330. With 2, it's 335. And with 3, it's 340. Now, we go ahead and add the units. We only need 1. So now, we have 341 in base 5 blocks.
Now we will be explaining the lattice method, except instead of addition, we will be doing multiplication, and we'd go ahead and do these 2 numbers. So what I did, we did the square, and then we put 1 number on top and 1 on the side. And then we, just like we did with addition, we just go ahead and divide the numbers and make them into squares or columns and rows. And then each little square, we draw a line diagonally, halving that square. So we begin 3 times 3, it's 9. 5 goes into 9 1 time, and the remainder is 4. That's why we did that. I'll explain the other numbers later. And again, 3 times 3, 1 and 4. 3 times 4 is 12. 5 goes into 12 2 times, and the remainder is 2. Now, with these anything that's multiplied by 0 equals 0. That's why everything is 0 on this one. And then 3 times 2 equals 6. 5 goes into 6 1 time, and the remainder is 1. And then again, the same thing. 4 and 3, which is 12. 5 goes into 12 2 times, and the remainder is 2. Again, with this, all these are the same. And it's just like that. You just add 4 and 4, which is this one, is 16. So 5 goes into 16 3 times, and the remainder will be 1. And the only different one is this one, 2 and 2, which will be 4. 5 does not go into 4, therefore it's a 0, and the remainder is 4. Okay, and then from here we just go ahead and add everything. So it's going to be just like we did with addition. We add it in this angle. So it's going to be 1 because 1 is by itself, then 3, 4, which is the 4, then 3, 4, 5, 6. 6, 5 goes into 6 one time. So we go ahead and add the 1 over here, and the remainder is 1. Then we add this, and it equals to 13. So the remainder is 3 because 5 goes into 13 2 times, and then it's the remainder of 3, of course. And then this is going to be 13 as well, so we go ahead and add the 2 over here, and then so on. This is going to be 15, so we add a 3 over here, and this is going to be 5 times 3 equals 15, so we go ahead and put the 0 here because there's no remainder. And then we go on again, 2, 4, 5, 6, the remainder is 1, we add it over here, and so on. So this is what we get. And last but not least, we add the 6 over here, 5, and then 6, and it's going to be a 1 plus 1 equals 2. So how you get your answer, you begin by your number over here, your product. So it's a 2, 1, 1, 2, 1, 1, then 0, 3, 3, 1, 4, 1, and you don't forget to put the 5 at the end because the numbers are in base of 5. We will now be explaining how to use the lattice method. In this case, we will be doing addition and using these two numbers, and they are both in base 5. And then what we did is where the total would be, we went ahead and drew a box, and then we separated the numbers into its own little group, and then we went ahead and drew a line diagonally in each square. So what we do, we just go ahead and add them. 4 plus 1 equals 5. So the first little triangle, or first half of the box, will be how many times the 5 goes into this. So in this case, it's 4 plus 1 equals 5. 5 goes into 5 one time, and that's why we put the 1. And there is no remainder, so we put a 0. Now we would be 4 plus 2 equals 6. 5 goes into 6 one time, and then the remainder is 1. So 5 plus 1 equals 6. And then 2 plus 0, 5 does not go into 2, so we put a 0 here, and the remainder is 2. And then for 4 plus 3 is 7. 5 goes into 7 one time, and so we put the 1 there, and the remainder is 2. 5 plus 2 equals 7, and then to get that's our first step. So to get our final answer, we just go ahead and add them like this. So it's going to be 0 because 0 is by itself. And then 1 plus 1 equals 2. 2 plus 1 equals 3. 2 plus 0 equals 2. And then just the 1 by itself. So this is your final answer. And don't forget to add the base 5.
Okay, so for this equation we have 112 in base 5 plus 201 in base 5. This is how we have it represented in base 5 blocks. And we have the demonstration here with the 5 blocks. So we're going to start in the ones place. 2 plus 1 is 3. So we will have to move these 3 ones over to this side. And then we have 1 plus 0 is 1, so we have 1, 5 to the 1 power. And 1 plus 2 is 3, so we are going to have 3, 5 to the second power. So the way that our answer would look in base 5 would be 1, 5 stick, and 3, 5 block flex. Our answer is 313 in base 5. For this section, we are converting from binary base 5 to decimal base 10. We have, for this example, we have 431 in base 5 form. Our first step is going to identify the base 5 place values. In 431 in base 5, we have 1's place value, 5's place value, and 25 place value. Our second step would be to multiply the place value by the number in its place. So it would look like this. There is 4 in the 25th place values, there is 3 in the 5th place values, and there is 1 in the 1's place value. So once you have completed the multiplication in these, your results will look something like this: 115 plus 1. So all you would have to do now is add them all up so you could get your decimal base 10 form, which would be 116.